is a framework. And what we're writing is an interface. So we're in the green layer. We cannot import anything from the Babylon engine into our thing. Because think about that. Think about the big picture. What that does is that makes our controller script dependent on Babylon.js code. We have no control over Babylon.js. They could quit making Babylon.js. They could go under. They could fundamentally change what Vector 2 is. We have no control over that. And what we don't want to do is have our code break because Babylon has done something that we had no control over. Also, let's say we want to go to Three.js instead of Babylon. We're like, you know what? Let's try doing our render, our 3D view. Let's do that in Three.js. If we build our interfaces, our controllers dependent on Babylon core, on Babylon Vector 2s, that means we have to like change everything to point at a different Vector 2. So a lot of these fundamental things you're going to see in Babylon, we have redone on our side. We own our own Vector 2 with all the vector math around it. We own our own Vector 3. We own our own ray. We own our own matrix. And what that does, and those are value objects most of the time. That's that very, very center. What that does is it makes us our own man. We can go anywhere. We don't care if we're using Babylon's vectors or, you know, all that stuff. We're using our own vectors, and we can do whatever we want after that. So, any questions on that? So, when you're importing these things, be careful, because it is easy to pull in Babylon, and you don't want to. We're going to bring our own vector in. And that one. So there we go. Now I have a Vector 2. This is our vector. Button is 0. That's primary. I wish we did an enum here, to be honest. I might go back and refactor this guy to be enums because I forget. His left button. Oh, yeah, go ahead. Oh, muted.
Try to Google it later.
Yeah.
Sorry, I really hate to ask this, but I'm really embarrassed. But enum, what exactly is it? Enum?
Oh yeah.
I've never actually heard that.
Oh yeah, an enum it comes from more object oriented. I know your background is more JavaScript. There's no enum in JavaScript. This is a strongly typed type. An enum. Let me show you. I'll show you that real quick. Yeah. So I know there's one here in entities. Here's an enum right here. It's a type. It's an enum, so it's like a const or a number or a type. App mode, and what it's saying is, app mode, whatever this is, can only be these two things. So if I come over here, let me just run down here and do this dot app mode. The main thing it does is watch this. This, well, this isn't a good spot to do that. Let me find a spot where it is good to do this. Yeah, it's I can bring it in right here. App mode. Let me do a constant app. A lowercase mode is equal to app mode. Notice I do all caps. I have brought in the type. You notice I'm importing app mode from that entities. And now you see I just have these.
Okay.
That's all it's doing.
Granted, I understand the logic of this sentence is not 100% correct. It's almost as if we're limiting a boolean to the amount of, almost like a boolean, but like it could be more than 2.
Yeah, exactly. It's a set, right? And so if we had this button as an enum, we could say it would be so much easier to say button dot primary, secondary, tertiary, right? That just is so much easier for me down the road and for you down the road when you're like, all right, is right click, is my right click button, is that button 2 or is that button number 1? I can't remember. I don't actually remember. I always have to like do a console log or something. So an enum would just take that away. We wouldn't have to worry about it. So that's what I mean by an enum. It makes a discrete list of possibilities. Okay. Get this out of here. All right, so good. So now we've got an event. We're just going to stub in some numbers. We actually don't really care about the pixel position. You can see I threw in a 2 and a 3. you guys will see throughout this test that the pixel position literally doesn't count. And we'll get to that. We'll get to that in a minute why. But we'll just start this out as a vector, as just what it is now. We've got a button, we got a position, a button number, and a down. All right. I'm going to paste that into there. Now, we have triggered our controller with the on down. What do we expect to happen? Well, when the primary mouse button, so there's a test. Let me just throw that down here. Check button for primary. I'm just going to throw a note. Oh, what the heck is going on here? Stop it. You know what I'm doing? I'm in stand-up on my desk. My desk goes up and down, and when I'm in stand-up, my wrists are at like a different angle, and my typing just goes to hell. All right, so it should send a ray into this use case. All right, easy peasy. Let me come into here. I am going to go ahead and just mock out. I know that use case, right? That use case we were looking at. It's got 3 things we're going to be worried about. Well, right now we're going to worry about one of them. So we're going to mock out. We're going to get, we're going to say constant mock try press is going to equal the jest function. And we're going to go to our controller, and we're going to go to that use case, and we're going to do try press is equal to mock try press. All right, we're going to do that. So now we have taken that use case, we've injected our own mock onto it, and that allows us to watch it. So now what we can do is on event down, let's grab this guy. We're going to do this, expect mock try press to be called. Okay, we're going to stop there. That's what we expect. I'm surprised it is being called. Let me hit save one more time. Uh-oh, we lost Philip. I wonder if his internet went out. All right, we failed. That's to be expected. So, again, back to our requirements here. When the mouse button is pressed, it should send a ray into the try press of the use case. All right, so we got a test for that. Let's hook her up. So on press, we're going to do this thing. Now it's going to get a little, there's a few more messy things going on in here. But what we're going to do is we want to do press on scene object dot try press, but we need a ray. So for now, we're just going to stub in array. Parametric line dot forward. All right, we're just casting array straight into the scene. It's a static way to form this guy up. We're not worried about the ray yet. This should pass. But we know that's not right. We know we should be somehow taking our mouse coordinates and somehow we got to turn that into a ray, right? Let's take a look at Pan and see how it does it. All right. Oh, this isn't a good one. This is, okay, that's not a great one. Here we go. This is a good one. Look at this right here. We have got this nice little function already built up for us. This Babylon is our Babylon. This is not Babylon.js. I regret naming it this in retrospect. But you can see this Babylon is coming from our app entities. So Babylon has a function on it called pixel to scene ray. All right. And what it does is it just takes a pixel location, a vector2, and converts it into an array. So we don't have to worry about all that stuff. So I'm just going to grab that. Nice. I'm going to come over here. I'm going to put it right here. Now, we're going to need Babylon. So let's just go ahead and do a private Babylon. And that's going to be a Babylon that is our entities. And we need to pull that off of this dot Babylon dot is equal to entities dot Babylon. There we go. Now, we need to pass this ray into here. All right. Now, there's some magic going on behind this thing that's going to cause this guy to break. Well, maybe it will. We'll see. It might not break. But we do need to make sure that this, we got to check this call and see what we're calling. Yeah, it's going to fail. And if we look up here, we're going to see this rejection that happens. The pixel to scene ray has not been injected. All right. Here's some little bit of deeper details. This function, Babylon pixel to scene ray, this is an injected function. So what that means is this function starts out empty. It starts out with an error, essentially. When we initialize our entity context, that starts out as an empty function that expects to be injected. And that's because we want our Babylon entity, our entity, to not know anything about literal Babylon code. Like, it can't be dependent. Other than the name, that's the only thing it knows is I'm something to do with Babylon. But if we go into this entity, I don't know if we actually can because it's in a package. But that thing starts out empty. And we actually inject this function into the entity at runtime. Because the code to actually do to convert a pixel to a scene ray, that is the actual literal implementation of that, does require Babylon. And so I'll show you what that looks like. But we come out here, and I think we have something in our Babylon setup, initialize Babylon. Yeah, right here. So, you know what? This is not specific. I'm just showing you how we set up Babylon so that we can do scene ray picks without knowing anything about Babylon, right? We don't want to know anything about Babylon, so how do we pull that off? So essentially, you can see that when we initialize Babylon, here's the actual Babylon code we're writing. We're creating our working canvas. We're instantiating our Babylon engine. We're making a Babylon scene. We're storing those things on the Babylon entity. We create some sort of renderer. But look at this. Babylon.pixel to scene ray. We make a scene. No, I'm sorry, that's wrong. We want to do scene pick. Babylon to scene pick. We make a scene picker. Let's go look at what that looks like. That's up here in Babylon entities. This is full of Babylon specific code. But what it does is there's this interface called a scene pick that is generic. If we go get the definition of that, this is our Babylon entity. The scene pick, it takes in a parametric line, returns a hit, world coordinates, and it's a what is this thing? Scene picker. Yep. Oh, it is the pick. It's like the actual pick. So this scene pixel pick. You see, we pick in a 2D position and we return a scene pick or undefined. So this function is injected later. It's a lot of deep technical stuff. All it's doing is it's allowing us to run. The reason why we do that is we need to write this controller in test-driven, but in test-driven, we don't have a Babylon scene. We don't have Babylon even running. We don't have a canvas. Nothing is rendering. So how would we write a control? How would we write this controller if it needs to pick, if it needs to create array, but we can't? If we can't do that scene pick, that what do we call it? Pixel to scene ray. This is the one we're trying to do. Pixel to scene ray, right? So what we do is we mock it. This is why we do injectable code, is because our test itself does not care about the nuts and bolts of taking a pixel and turning it into an array. It doesn't care. It just expects somebody else is going to handle it. That's somebody else's responsibility. Let's just fake it. So we're going to do that. We're going to fake this scene pick. So let me go back to my test. Interface adapters, controllers, mouse, Here we go. Back into this one. And we are going to fake constant mock. Or we're going to do a fake scene ray. It's going to equal a jest function. And this fake scene ray is going to, let's see, I want to keep my ray out. So I'm going to do a constant faked ray is going to be, actually, I'm just going to call this scene ray. Scene ray is going to equal a parametric line. And let's get, I don't really want it to be like a forward or an up. I want it to be a little bit funky so that we can check it. So let's see, we're going to do, this is how we do array from point and direction. So array in 3D space, it starts at a point and it goes in a direction. So you give it a vector position, a 3D vector, and you stick and you say, I'm going to go that way. So I'm going to give it kind of a random point and ray, and that's going to create a kind of a unique-ish ray that we'll check for. So our point, we're going to say, is it a make vector? Is that what it is? Or is it a new vector? Yep, new vector 3, we're going to call this 1, 2. We're going to start our ray at 1, 2, 3. And we're going to point our ray, and that takes a direction. So our ray is going to start at this who cares point of position 1 in the X, 2 in the Y, 3 in the Z. And it's going to point in vector 4, 5, 6, whatever that is. It's going to point somewhere. All we're doing is we're making a ray. All right? Now, so there's our scene ray. Our fake scene ray is a fake make scene ray. We're going to have it return this mock scene ray. So mock return value is going to be the scene ray. All right. All right. So this will all start hopefully making sense in a second. I'm going to return these two things. Right now, last thing I need to do is do our entities.babylon.pixel to scene ray. It's going to be our fake make scene ray. All right, that closes it down. So, recapping here. Let me separate these two guys out a little bit more. First thing we do is we make some sort of ridiculous ray, our scene ray. Then we make a fake way to convert a pixel into a scene ray. We don't actually care about the pixel because we're not going to do any math. We're just gonna make a jest function that is that faker. We're going to tell it to return this scene ray, and then we inject that faker into our Babylon pixel to scene ray. Okay? Now what we can do is we can expect our mock try press to be called with, and we can bring in our ray now, our pick ray. Ray, what do we call it? Scene ray. Scene ray. Should be called with this. All right. Is that going to pass? Then we'll circle back and talk about what we're doing. What's going on? Oh, I think my tests are stuck. Let's kill them. Do this again. Do it. Oh, we got to fail. Ooh. Internal promise. Uh-oh. Oh, man. Mouse press on scene object. We have a promise getting rejected? Uh-oh. All right. Well, let's see what's going on. Is it... Oh, look at that. I said mock rejected value. This is not a reject. This is a mock return value. Mock return value. All right. Let's see. That might have got us. That's what got us stuck. You going to be able to get out of this, Jest? There we go. Okay, so what that did was that set up our jest function as a promise, and it's not supposed to be a promise. There we go. We passed. All right, so a lot of funky going on here. Let's circle back. Remember, this isn't... Okay, so let's take a moment and look at this map real quick. And this controller is... It's taking input from a mouse system. It's using Babylon to form array. And then it's calling a jest function. Now, what we're doing is we're mocking a lot of this stuff. We're mocking the Babylon, the creating of the array. Because that's not the controller doesn't need to test that. We're going to assume that whoever wrote that wrote that correctly. The use case, we're going to mock that too because we don't really care what happens when you call the use case. We just want to make sure that we're calling the use case correctly. That's all this controller is worried about. The input, we don't care how the input is generated. We're just expecting that that's all taken care of, and we just get triggered to do what we're doing. So there's a lot of mocking going on. You'll find that there's a lot of mocking going on with controllers because we're staying focused on our task, which is on press, we form array, and we send it to the controller. That's all we need to worry about. All right? Let me get back into this. All right, turn off my marker. Oops, where's my marker? There it is. Okay. Oh, shoot. Get out of here. What happened? What? Sorry, guys. I'm having trouble here. I can't get out my marker. All right, here we go. Back to this. All right. So we're passing. What we've proven now is that, go back to our mouse scene input. We have taken an on-down event. We have turned this into we have faked it. We've mocked it. We've injected our own jest testing to really define what this will do. We don't care about the pixel coming in, and we injected this to return our random ray, well, not random, but our arbitrarily created ray, which is this. Then we make sure that we tested that ray that was returned by our injected function is sent to our injected use case. And that's all we're doing. All right. So now what we can do, well, let's check primary. So it does not trigger the use case if the button is not primary. The primary button. All right. So that's part of our requirements doc is when the primary button is pressed, it should cast that ray. All right, so let's do this. We're going to grab all this stuff. But this time, we're going to set our button to number 1, and we expect this not to be called, right? Staying focused on our job here is just checking for that. I'll bet that'll fail because we didn't write that test in there. All right, great. So now what we got here is if e.button is not equal to 0, return. So we're just checking for that button. Easy peasy. All right. I'm surprised it didn't work. Let's give it another save. Slowpoke. Hey, past that. All right, we got that tested. Moving on. I'm going to jump down to the unpress. We'll get into the movements in a second. Okay, actually, no, let's do it. While pressed, if the mouse moves, call update press UC. All right, let's do that. So we're going to bring in, let me find the right way. I'm going to peek at my definitions real quick. We're going to do an on move. All right, let's grab this guy. come back over to here and come back over to here, and we're going to do on move equals this, and here we go. All right, so now it updates the use case when the mouse moves. All right, so now let's do this. Let me find a mouse move example. I make sure I get this right. Is there a mouse button down? Maybe it doesn't matter. I don't think it matters because we don't use those things. All right, so we're just going to keep on in here. We're going to just kind of grab this initial stuff here, and we're going to do mouse input event, but this time we're going to do on move. And now we expect something else to be called. What do we expect? Let's go back to our ref. Update press. So let's go ahead and get back to our controller up here. And we're going to do another mock, constant mock update equals just function. And again, we're going to inject that now, controller dot on, no. Press on scene object update press is going to be equal mock update press. I'm going to rename that to mock update press so it's a little bit better. All right, now let's return that in our rig here. Now what we expect is we're going to change this to mock update press, and we expect that to be called. All right, let's see if that works. Probably shouldn't because we didn't hook anything up. And let's just grab this, copy that, put that into here, and we're going to call this mock. No, not mock. Update press. All right, that's going to probably call that. Now, we can see some edge cases here. I can see some edge cases. One, if I don't get past this, I probably shouldn't be updating, right? If I'm dragging around, essentially, I think I want a local thing that says, all right, if I don't get this going, if I don't call this try press, I probably don't need to worry about updating on move, right? We could also just look for button numbers. But what I'm going to say is, we're going to change this a little bit after a successful press. So I'm going to go ahead and call this on down as well, just to do that. And then let me add another test in here that says something like does not update the use case without on move, without an on down event. I don't know how we would get into this, but essentially if we don't have an on down that gets us going, then we should not be calling on move. So we're going to do this not to be called. So let's see. That's not, it should fail. So then what that's going to do is going to introduce this local variable I'm going to do over here. Yeah, there we go. So now we're going to do this thing called private is pressed equals false. All right, and we're just going to track this guy. This is going to be our little internal flag, and we're going to do this dot is pressed equals true. Now, then down here what we can do is if not this dot is pressed, return. All right, so there we go. Because this on move is going to happen anytime the mouse moves. So as I'm, even without a press, it's just always going to be updating this. And so we want to kind of pigeonhole that in. If not, this is pressed. All right, let's see. I expect that to work. All right. Now, what else do we want to do? I know that I need to unset that flag at some point. So I think I'm going to do that anytime there's a press. We're going to start this thing out that this dot is pressed. Actually, let's work into that. We'll work into that. Let's do a different thing. So let's do another one, another use case. If we are pressed, why didn't that work? Oh, if we are pressed, but let's say the press was not the primary button. We shouldn't be doing this either. And actually, I don't think it will, but let's test that. Let's grab this one and says does not update the use case after a non-primary press. All right, so we're going to do this as button 1, and now we expect this not to be called. So essentially, we're not checking. If we didn't do if we didn't do primary, we also shouldn't be updating the use case. Essentially, we only want this on move to be firing if we had a successful press and we're moving along. All right, great. Any other edge cases? All right, I saw one other one in our thing. If a different button is pressed while the primary button is pressed, it should call unpressed. Ooh, that's a complicated one. Let's set that to the side for a second. Let's do our last one. When the primary button is unpressed, it should call the use case unpress. So let's do that. Let's find our unpress. Again, I'm just going to jump to my definition of these guys, and we're going to do on up. Here we go. Get back over to here. Same kind of setup. We're going to do this on up. We got this is going to equal this function. It's this. All right. Now let's go ahead and write our tests. It calls. What are we calling on the thing? Unpressed on the use case after a successful press has been lifted. All right, so here we go. This time we're going to grab all this stuff again, except I want to use the good one up here. We don't necessarily care if there's a move or not, so I'm going to take this out, but I'm going to do an on up. Whoops, there we go, on up. Now we expect we got to do one more injection on our use case up here. We're going to do a constant mock unpress equals just dot function, and again we're gonna inject that fake function into our controller. Pressing object use case unpress equals mock unpress. All right, and we're gonna return that down here from our test rig. All right, there we go. So nice. Great. Now we expect this mock unpress to be called. Now, actually, our unpress, let me make sure. I think our unpress does not take array. It doesn't. The unpress doesn't need to know where the pick was. It's just letting us know the lift was happened. We can assume that it was, if we haven't any movement, it's where the press was. If we have had movement, it's wherever the movement was. So we do not need to check for a particular array. So it's just going to be called. All right. Now let's see what happens. Probably going to fail because we don't have any code in here. All right, but on up, we're going to do this dot pressed objects unpress. All right, that should go. But now we know, we shouldn't be calling unpressed if we didn't initiate the press. So let's go ahead and set that up. So let's take this same one, and we're going to say does not call if there was no successful press. So I'm just going to remove this on press, and we're going to say not to be called. So if there was no press to begin with, I don't know how we triggered it, but somehow we got an on up, and I'm surprised that worked. And we should not call if we're not tracking, particularly if we're going to use this line right here. Should fail. There it does. Now let's make it pass. There we go. All right. Now I know that we should reset this guy a little bit. So I don't know how we would actually test for this, but let's see. How would we test for this? Well, let's go ahead and finish what I know is we should put is pressed back to false. But we should write a test. We shouldn't just write that code. There should be something that tests that. And I'm not quite sure how to do that yet, what the use cases are, but we'll figure it out. So here we go. I know what we can do. All right, last thing in our requirement stock is if a different button is pressed while the primary button is pressed, it should call unpressed. So essentially, this is a weird use case where the user has pressed on one thing and then they've somehow hit another button on their mouse. We should just unpress. We don't know what's going on. We don't know why they're doing that. But the requirements is telling us, all right, call that an unpress. So let's do that. It calls unpress if a different button is pressed after the primary button. All right, we could fake that out. So let's do that. And all right. Oops, I need one more round bracket, I think. There we go. All right, so let's stop this guy. Let's make this guy work. Let's get rid of this. Don't need that. Don't need that. Grab this. We're going to call this press 1. And we're going to call this press 2. All right, and now we're going to do this on down with press 1. And we're going to do an on down with press 2. And we expect unpress to be called. Oh, wait, we need press 2 to be a different button. There we go. All right, so weird situation. They press the first button. They press once with primary. Then they come along, they press twice with secondary button. We should call unpress. And so what we can do is, okay, here's how we could do this. We could say, if this dot is pressed, and, well, let's see. Well, we'll just do it hard for now. We'll do E button is not equal to 0. We're going to do this dot is pressed equals false, and we're going to, actually, we're just going to call this dot unpressed. Yeah, this dot on up. No, we're going to call this right here. All right. See if that passes. That should pass. All right. Now, I figured out how we can check to make sure we unset our flag. Essentially, we should do this. It stops sending on moves after The press has been released. All right, so let's just mock that out. So what we're going to do is we're going to grab this setup. All right. And we're going to we're just going to run through a whole cycle. The user pressed, the user moved, the controller dot, controller, come on, give me some love here. We're going to do a release. So the user pressed, they moved, and on up. We're going to pass that event in. Now, we're going to come up here, and we're going to do our mock update is going to mock clear. So this is the use case mock function that's listening for updates. We're going to clear it out, and then we're going to go ahead and do another move. We're going to say the mouse is moved because this is what happens. The move doesn't care if there's a button or pressed or not. The move is always going to let you know. But we should not. Now we expect this mock update to not be called. To not to be called. All right. Now, that is probably not going to happen because we got to reset this is pressed down here on the up. So this dot is pressed equals false. Did that pass there for a second? Did I not do a good test? Let's see. Give me a second. Let's see. Mock update press. Okay, let me save one more time. Oh, yeah. Guessing this will. Oh, I did not expect that to pass. So here's a good little test-driven development. You try to make your test fail, right? Because you want to make sure your line of code is doing what you think it is. But mine is passing. And I want to understand. Here we go. There's another reason why it's failing. It's because we weren't using the primary button. So, there we go. Now, this should fail. Let's see. There we go. Now, if I undo this line, this should get it to pass. Looks like we don't need a parametric line up here. All right. Now, I did see one more way that this could fail. You notice we're calling unpressed here, but we're not calling this is pressed. I think what I'm going to do is I'm going to actually force this through this call. So instead of doing this, I think we're going to do this on up, and we're going to locally do it, and we're just going to pass in our event. There we go. And that should let everything still pass and everything should still be good. All right, great. I think this is it. Let's see. All right, I think we have our things. We have a rule. We have our requirements doc completed. We have tests for all these things. One more step. All these controllers are made with a central factory. So whenever you add a mouse controller, you need to make sure you add it to this factory to make it. This is called on main, and this is what instantiates everything. So now we've got new mouse press on scene object, and we're going to do entities. And that's what creates it when we at runtime. Okay. Wow, that went longer than I thought it would. Oh shoot, I got a call in 10 minutes. So, any questions on that? I know there's a lot going on in there. A lot of mocking, a lot of kind of advanced jest stuff. And, I don't know if you guys have ever written controllers before where you're dealing with kind of complicated mouse inputs and presses and drags and stuff like that. If you have, you'll notice that they're really hard to write if you're not doing test-driven development. It's really tough to to check all. You have to like manually try to hit these edge cases. Like you're trying to click left and you click right, and you make sure it does what you do. That's it. I mean, that's how I used to do it. But notice the beauty of our test driven. We're able to like run through all the edge cases we can think of. Like, all right, I mean, you can kind of go crazy on this. What if the user clicks 3 times and then right clicks? Should that do something? You know, you can actually get into, you can actually start doing drags and start doing math. When you get into this a little bit later, you can do time delays. You can check for double clicks, stuff like that. So it's really, I know it feels kind of complicated, but it gives you so much more power and reliability as a developer to know that you're really covering all your input edge cases. And then later when we start getting bug reports where somebody's like, hey, if I press on this and then I, drag to this, you can write tests for that in here for those situations and get a better picture about what's going on and really be confident that you're solving the problem down the road. Okay. Any other questions, guys?
Yes. So, in this control also, it was about mouse controller, is that right? So, and I know there are other controllers about to touch and G-space.
Yep.
Such as stylus. So I think the basic logic about the controller is the same about the mouse, touch, and G-space. So can you describe me about the touch and G-space in briefly?
Yes, for sure. Good point. So,
Okay,
yeah, so let's talk about touch real quick. We'll compare. Let's do mouse pan. So panning again is just like clicking and dragging. It drags the scene around. It pans the scene around in front of you. We have a mouse pan and we have a touch pan right here. Oh, we have touch. We do touch with a pinch. So it's just like using your phone and you're panning around on photos. Panning, we use 2 touches. So let me look at that. It's going to be some complicated math. But the key here is the rules are different. When we want to start our panning, we need to be looking for 2 touches. If there's 3 touches, it might be something different. If it's 1 touch, we're not supposed to be panning for our rules. On top of that, the ray that we're shooting in to define what we're panning comes from the average between your 2. It's coming from a point in the middle. And there's actually a pinch part of it too. So the whole setup for panning is completely different with touch. And maybe orbit would be a better one to think about. Orbit is you touch once and you spin. You're spinning the scene underneath, right? We want to spin underneath your touch or your mouse click. We want that rotation to happen directly underneath your ray. So this one is a little similar, except there's some different rules. Notice we're got to check touch length. How many touches are we talking about? We're not looking at a primary button anymore. We're looking at touch count. So this is fundamentally different. But it's because it's around touches. Stylus is even more interesting because the stylus lives in the 3D world. The stylus doesn't even have a pixel position, right? We can kind of backwards figure out stylus pixel position. But a stylus is actually, there's no mouse, there's no touching a pixel. When you're thinking about a stylus, it's in the 3D world. So you can grab something and you could drag it towards you if we were doing that. You can't do that with a mouse. You might be able to roll, but you can't press and drag. And you can't press, drag, and rotate at the same time and pick it towards you. So the math for figuring out how to go from stylus values to what we just did is a lot different. Primarily, the main difference between a stylus, what we just did, and let me pull up the mouse press is, where's my I lost my mouse. Don't you hate it when you, there it is right here. When we use the stylus, we know the ray that's coming out of the stylus. We don't have to do this pixel to scene ray. That's the primary difference. Is the ray comes from the stylus. Because we're watching this guy. This guy actually, there's a representation of this in Babylon. And it is casting a ray. So this is the key difference. This line right here is the key difference. Is right there. Yep.
Oh, I see.
Yeah.
Okay.
Yep.
So thank you for your
Yep.
description.
Yep.
Just thank you.
All right, guys. That was a long one. That was actually more talking than I expected. I think because it lives in this space between use cases and Babylon, as we get further and further out towards Babylon, life gets more and more complicated. So Babylon is hard. Babylon is going to be the hardest thing we deal with. And so this thing touched Babylon. And so you guys got to kind of get into ray picking and vectors and stuff like that. And so that's probably why this one took a while. So, but
So about the Babylon, so you should have a lot of knowledge and strong
yes,
about the geographical. Yes.
yeah,
Okay, so it was about mathematical problem.
yes, yep,
Okay.
yep. We'll get into all that stuff soon. But all right, guys, I'm gonna have to shut this down unless there's some more questions. I gotta get ready. Got a meeting with the big boss in 3 minutes. So,
Good luck.
all right, thanks, guys. See ya.